Hi ladies and gentlemen, this is Mr. Green and this is another in my series of lessons for Algebra 1. As we start this new unit, I wanted to make certain I covered some materials for you and make certain you understand what's going on here a little bit. So what we're going to be looking at is what you do when you play some video games. Well, of course, you try to make the most number of points that you can. Along the way, you may make moves that cause you to lose or subtract points, but you also try to make as many as you possibly can. In this lesson, we're going to review how to subtract integers, how to determine if a number is a solution to an equation or an inequality, and how to solve a literal equation. So let's look at a couple of things here. First of all, if we're subtracting integers, remember, integers are the ones that are the numbers with the negative ones as well, right? Positive and negative numbers. So let's look at this. We got negative 75 minus a negative 66. Well, when I see minus a negative, I automatically draw two lines like that, reminding me that it's going to be plus 66. Now, the minus 75 is bigger, so that means my number at the end is going to be a negative number. So let's look at this, 75 and 66. Well, the difference between those is 9 units, right? So let's see here. If I go from 66 to 77, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75. Yep, that was 9. And then you couldn't see me there, but I was actually counting on my fingers. That's what I do. I actually use my fingers to count them sometimes. So this would be a negative number. We know it's negative because the negative is bigger, negative 9. Let's try it again. So we got 10 minus a negative 97. Two minus signs, going to make it into a plus. 10 plus 97 is 107. I don't even have to think about that one too hard. Okay? 38. It's a plus 38 minus a plus 63. Well, if I'm going to be subtracting it, that means I'm probably going to get something negative. Okay? So let's see here. 13 minus 8, that'd be a 5. And 5 minus 3, that'd be a 2. And so I'm going to get a negative 25. I'm going to check this by adding it, okay? The 25 added on to 38 is going to be 33, and 20 more would be 53. That's not right. Let's see here. 13 carrier 1, 40 plus 2 is 63. Yes, negative 25 would be my answer there. Okay? Number 4, positive 59 minus a negative 3. Switching these both to plus signs, 59 plus 3 would be 62. Negative 16 minus 33. Well, if I'm at negative 16, think of a number line here. Here's 0, here's negative 16, and I'm going to be subtracting 33. That means I'm going to be going this way. Okay, that means it's going to get more negative. So I'm going to add them together there and get 49. And I know it's more negative, so it's going to be a negative 49. Okay? 13 minus a 1, well, that's easy, 12. Okay? Hopefully this little review on how to add integers helped you a little bit understand what's going on there. Okay? We're going to look at some inequalities now. So what's different about inequalities? Absolutely nothing. We're going to solve them the same way we've been solving equalities, equations. We're going to solve them exactly the same way. We can add positive or negative numbers to both sides of an inequality. It will not cause any problems. So subtract 6 from both sides of this one, just like I did right here, and I get 3x is greater than 24. I can multiply and divide inequality by any positive number, and it won't cause me any problem whatsoever. So divide by 3 on both sides of the equation. I get x is greater than 8. That's my answer. Great big watch out right here. Okay? This says if you multiply or divide both sides of an inequality by a negative number, you reverse the direction of the inequality sign. What? You gotta show me what that looks like, okay? Here's the problem. 25 minus 7x equals is greater than 39. I'm going to subtract the 25 from both sides. Minus 7x is greater than 14. I'm going to divide by the negative 7. And see, I'm dividing by a negative 7 on both sides of the equation. When I do that, I get x on this side, obviously. I get negative 2 on this side. Notice what happened to the inequality sign. It flipped around the other way. That's what this watch out is telling you here, okay? You divide by a negative number, reverse the direction of the inequality sign. Just turn it around the other way. If it's a less than or equal to, make it a greater than or equal to. If it's a greater than, make it a less than. It just flips around the other way. So let's try to do some of this. I want to graph some of these. Same way as I was graphing when we were graphing equalities. I'm going to start with the intercept here, the minus 4. I'm going to put a point right there on the y-axis at minus 4. I'm going to count my slope out. Remember, slope is rise over run. So I'm going to move up 5 and over 2. 1, 2, put a point right there. I now have 2 points that I can connect together. It is a greater than or equal to, so when I connect these together, I can use a solid line like that. Okay? Solid line. Now, would I put arrows on the end of it? Yes, I'd put arrows on the end of it. Okay? Now, this point right here, 0, 0, is not on the line. Watch what I'm doing here. I'm going to put 0, 0 in for x and y. So this 0 is going to go in for y, 0. Greater than or equal to 5 over 2 times, this 0 is going to go in for x, 0 minus 4. 0 is greater than or equal to, well, 5 over 2 times 0 is 0, minus 4 gives me a minus 4. Is 0 greater than or equal to negative 4? Yes, it is. This point must be in my solution set because this was true. If it's true, I'm going to take my little shading and shade on the side of the line that has the 0, 0 on it. How do I decide which side to shade on? I don't memorize things. I don't try to remember which side to shade on. I pick a point not on the line and I test it in the problem to make certain it's true. If that point is causing it to be a true statement, I shade that side. Well, what if it's not true? Let's see if we can't get one here and see what happens. I'm going to do another one here. Using the plus 2 to start with, I'm going to go right here to plus 2. Then I've got a negative 2 slope. That means I'm going to go down 2 and over 1. There's my other point. I've got a greater or less than or equal to sign, so I'm going to draw a line. It's going to be a solid line going through both those 2 points. Okay? Everyone with me on this so far? I'm going to do the same thing. I'm going to pick this point, 0, 0. Stick it in for x and y. 0 less than or equal to negative 2 times 0 plus 2. So that's 2 is greater than or equal to 0. Well, that's, once again, that's true. So which side am I going to shade? I'm going to shade the side that has that 0, 0 on it. Okay? So that'd be this side over here. Now, I'm sure I'm going to get this question. If we see a question like this on the test, do we have to actually do the shading? Yes. Yes, you have to do the shading. Yes, you have to show me that you know which side you're shading. Okay? Let's do another one here. We're going to start at positive 5 this time, way up here. My slope is 7 over 3. Well, I'm actually going to go down 7 and then to the left 3. 1, 2, 3. Okay, why did I do that? Well, because I didn't have any room to go up. Okay, and if two negatives make a positive, I could go down into the left and it still made that positive slope. Okay, there's my line. Ta-da. Okay, so I'm going to pick 0, 0, put it in here. So it's going to 0 greater than 0 plus 5. 0 is greater than 5. Is that a true statement? No. It's a false statement. So which side of the line am I going to shade this time? I don't want the 0, 0 to be in the correct answer. So I'm going to shade the other side of the line. See how when I got a false statement, I picked the other side of the line to shade? Not the side where the 0, 0 was located, but the other side of the line. Okay? One last one, see what we come up with. Negative 2 here. That's one of our points. Our slope is 2, 5. I'm going to go up 2 and over 5. And just to show you that this still works, I'm going to go down 2 and backwards 5. And I want to show you that the line will go from here through that point there to that point there. See? It works if I go in either direction, but you just have to make certain you're counting the slope out correctly in every case. Now I'm going to do the same thing I've been doing. I'm going to pick 0, 0. Do I have to pick 0, 0? No. But look what it does. If I pick 0, 0, what does this x value go to? It becomes a 0. So I get 0 less than 0 minus 2. 0 is less than negative 2. Oh, that's false. 0 is greater than negative 2. So I'm not going to shade the side with 0, 0 on it. I'm going to shade the other side. You guys see how I'm picking these out and doing them, okay? I am not memorizing anything. I'm not trying to remember what side of the line to shade, and I'm not going to get myself confused by that. I'm going to actually test it every time to make certain I know which side to shade. It's not that big a deal if you can pick 0, 0. What's a situation where you wouldn't pick 0, 0? Well, a situation like that would be if you had y equals 4x. See, I've got nothing over here on this side. Then when you're graphing it, you're going to start at 0. You're going to go up 4 and over 1. Your line's going to look like this, right? Well, it's going through 0, 0. So what point do I pick? Any point not on the line. So let's just pick the point 1, 1. That's not on the line, is it? No, because it goes up here to 4, right? It's going up 4 and over 1. So I know that 1, 1 is not on that line. So I'm going to use that one. 1, I'm sorry, I said less. Y is greater than this, okay? So I got 1 greater than 4. Is that true? No, that's false. And so knowing that that's false, I'm going to pick the side of the line where that is not, where 1, 1 is not, and shade the other side of the line. You see how I'm picking out what side to shade? And even if it was going through 0, 0, I could pick out the other side of the line or pick another point not on that line. Okay? Hopefully this helps you understand how we're going to do inequalities and how we're going to do graphing of inequalities. I'll talk to you next time.